For our presentation, we studied the effect of bullet selection on shooting precision. Following the title are the group members. I'm going to start out with our first topic, which is background information. I'll walk you through a basic 17 HMR cartridge. First, it's a rimfire cartridge, meaning on the diagram, the rim labeled 4 is the primer. That's what ignites the powder. Moving forward is the jacket or casing. Although there are multiple types, we use brass for all 4 cartridges. The casing houses the propellant, which moves the bullet forward. Number 1 on the diagram is the bullet. This is what we changed between our 4 groups. Now, I'm going to hand it off to Tommy to finish up the background information.
With this experiment, we wanted to identify and specify differences in precision for different bullet types of the same caliber. To find the precision, we measured the group size, which is our response variable. It is defined by the diameter of the small circle that can contain all shots fired measuring from the center of the bullet holes. The factors we are taking into consideration are bullet type and grain. We use 16 grain hollow point, 20 grain full metal jacket, 20 grain soft point, and 17 grain polymer tip cartridges. Now, Alex Rojas will explain our experimental process.
For the experiment process, we went to a Phoenix open range where we used a Ruger Precision rimfire Magnum rifle. The rifle was attached to a fixed metal vise for better precision and repetitions of the shots. Paper targets were stapled to a fixed wooden structure situated 50 yards away from the rifle. To collect the raw data from the bullets, we used a digital caliper, a digital scale to measure the diameter, length, and weights of 4 different groups of 30 bullets. Now Matt will explain the data analysis.
To begin the data analysis, we took photographs of each of the targets at a flat perspective to decrease error due to optical distortion. As Tommy introduced, the response variable is group size, which was measured in MATLAB using the image processing toolbox. Shown on the right, the distance between the furthest bullet holes is measured in pixels. From the 1-inch standard grid pattern, a scale is determined in order to measure the group size for a cluster of bullet holes. Each bullet type had 3 samples, or in other words, shot clusters, with 10 shots each, for which the mean and standard deviation is determined for each bullet type. Alex will now talk about the analysis techniques used.
In order to accept or reject our null hypothesis, we ran a t-test on the group sizes of each bullet type. Every possible combination of bullet type was tested, and the t-values, degrees of freedom values, and p-values were outputted in the following table that Aaron will discuss in the conclusion section.
From the t-test, we can see that the mean group sizes are indeed different from each other. However, the exception to that is the type 1 and type 4 combination, whose p-value of 0.0967 falls below our decided significance level of 0.10. By the results of the test, the mean group size of type 1 is supposedly the same as the group size of type 4. If you look at the standard deviation of type 1's group size values, you'll see that it's actually quite high in comparison to that of the others. From the perspective of the t-test, then, it's actually quite possible that type 1's mean group size is equal to type 4's simply because the variance of the bullet type 1 dataset is so high. Therefore, we conclude that the group size of type 1 is not equal to the group size of type 4, as type 4 has the smallest group size. Since we measured the precision from group size, with smaller group size meaning higher precision, we can order the bullets from most precise to least precise in this order: 20 grain jacketed soft point, followed by 20 grain full metal jacket, and then 17 grain polymer tip, followed by 16 grain hollow point. Now we're going to wrap up with a summary from Gerwin.
Although our current experiment accomplished its objective of showing difference in precision, there was not enough data to conclude whether the precision was from the weight or type. To test the effects of these factors, a multi-factor experiment with a total of 36 runs would be necessary. This process would give more thorough information as to which factor affected precision the most. Thank you.